I wasn't meaning for this to really be a humbling experience for you, but hopefully you got some qualities of a parallelogram. Um, okay, it is a quadrilateral. So what do we know about every single quadrilateral?
Four sides.
Okay, it has four sides. It has four interior angles. Got it? What else do we know about every single quadrilateral? Yeah. Yeah, that's going to go like right here. We're going to say opposite sides are going to be parallel. Okay, and that's a parallelogram. Specifically quadrilateral though, the sum of the interior angles has to be what? It has to be 360. That's the quadrilateral. Okay, so those first two are basically because these two are quadrilateral. These right here are because it's a quadrilateral. Okay? Opposite sides are parallel for a parallelogram. That should be pretty obvious. That's why it's called a parallelogram, is because the opposite sides are parallel. What else can you say about the opposite sides? They're not just parallel, they're also congruent. They're the exact same length. Okay? Opposite sides are parallel, opposite sides are congruent. What about the opposite angles? Opposite angles, they're also congruent. Okay? We're talking about opposite sides, opposite angles. Let's talk about, instead of the opposite angles, let's talk about the consecutive angles. Consecutive angles, could they also be congruent, or they have to be something else? They have to be supplementary. Okay? Supplementary. Okay? And this is where we're at so far. I think all of these are pretty easy for you to digest. Wow, I can't even say that. Digest. And we're going to look at some extra properties today that are going to really make these things hopefully a little bit clearer for you. But there are some other properties that exist when we talk about parallelograms. Okay? For instance, we could talk about their diagonals. Okay? We could talk about their diagonals. And we'll look at those here in just a little while, the diagonals. You guys have your 3 and 1 in front of you. Here's what I want you to do in your 3 and 1. The very first part says, use the following graph paper in your 3 and 1 to create a parallelogram named ABCD. So you need to draw one. Okay? Let E be the intersection of the diagonals. Basically draw the diagonals in there and mark that E. Label the parts of the parallelogram and show any special relationships. So I'm going to pass this out to you guys. I want you guys to work on this for just a second.
Nothing much. Oops, sorry.
If those four already got the, I think. One of those. You don't have to do that, people. So, ladies and gentlemen, you are using your 3 and 1 right now. You are, Andrew, you're using your 3 and 1 right now. You are creating your own parallelogram that shouldn't take very long at all. Raise your hand if you do not have a notes page right now. Everyone has a notes page now?
We need one. I don't have one.
You need one more, huh?
Four. We need four. We got 8. It's in my slide.
So everyone has a notes page right now, correct? Okay, if you're drawing a parallelogram, you are labeling stuff. You should be done in about 20 seconds. We're making parallelogram ABCD. Again, when you name when you name shapes, it has to go around at consecutive angles like this. So it goes around like so, and also so the intersection point and E, so we should be there. Is everyone there already? Excellent. Okay, we're looking at the slope. We're looking at the slope of the first line, AB. Yours is going to probably be different than mine, but when I look at this, I'm looking at my slope here. My slope is rising 0 over a run of 6. So mine's 0. I don't know what yours is, but mine's 0. Yours is probably going to look different than mine because hopefully you didn't copy after me. My slope at DC is also going to be 0. Slope is just rise over run. My slope of AD is I go up 3, I go over 1, so I have a slope of 3. And the slope of BC is also going to be 3. That's really nice. Okay. So hopefully that helps us figure that out. Next thing we're going to look at is you are using your 3 and 1, correct? Okay. Use your 3 and 1. What it wants you to do is it wants you to actually measure these, it looks like 10 pieces here. To measure those 10 pieces of whatever your shape is, to measure them. I'm going to have to estimate mine, whatever mine are going to be. But you're actually measuring these. Maybe use centimeters and maybe use decimal places. And honestly, if you do it correctly, you should get some really good results here. So use maybe centimeters or millimeters. I don't care what you want to use. Or don't use inches, though. It probably won't work. But then measure these 10 pieces on your own parallelogram.
How do you figure out this one?
Rise over run. So from A to D, it goes up 3 over 1. From C to B, it goes up 3 over 1 and twice. 3 or 3 over 1. If you drew it differently, you're going to have different results. It's fine. Oh, it's going to be 3 squared root of 2. I'm going to say... What are you talking about? 1 point? These are all lengths. These all mean lengths. There's no symbol of them that means length.
On AB, you have to 0.
My slope is 0. Because it does not rise any over whatever it doesn't run. It runs 6. So 0 over 6 would just simplify to 0. Yours might be different depending on how you drew it. Oh, yeah. Actually, that one's going to be... These are very tough for me because I have to sort of estimate mine. Okay, I'm sort of guessing on mine. Do not guess on yours. Just measure yours. Use your ruler, measure them. That's why you have this in front of you. I'm not exactly sure. Mine are right. Hopefully, if you guys know some of these patterns and everything, hopefully you'll be able to let me know if I did something wrong. I don't think I did, but we'll see how it turns out. Right, you again are measuring each of these 10 sides or 10 pieces of it. Slope is rise over run. I'm surprised how many people have the exact same parallelogram as I do. Maybe I shouldn't be surprised, but I just thought in the United States we really try to foster creativity So draw.
I was already drawing this one.
I'm surprised when I look around. A lot of people have the exact same one that I have. It's really strange. Okay, let's talk about this really fast. Do you guys notice any patterns on yours? Not mine, on yours. You notice any patterns? Say that again. One side the same as the other. So in other words, what he's saying is he's saying that the opposite sides are congruent. And also the same thing up here. These opposite sides are congruent. Okay, opposite sides are congruent. Thank you, Sam. Opposite sides are congruent. What else? What about the slopes? Yeah, what do you have?
Like DE is congruent to EB.
DE is congruent to EB. So if I was to draw this, it'd be like 3 marks here, 3 marks here. So E actually bisects that diagonal, right? You'd say that E is the midpoint or E bisects that. Is that also the same for this one here? So I don't know. I'm going to write IB here, IB here. That's a 4th piece there. So those would also be, E would also bisect that diagonal as well. Okay, what else? What about the slopes? Where? All 4 of them are the same?
No, slope AD is the same.
Okay, so opposite sides are also going to be parallel, which is what we talked about just a second ago. And opposite sides are also parallel. Sounds good to me. Are the diagonals the exact same length? Are the diagonals the same length? They're not the same length. That's on purpose. They're not the same length. So mine, I said, was 8, which I'm just estimating. I don't have a 3 and 1 big enough to figure this out. But then those aren't half the length. This one was 6, and these aren't half the length. Okay? Please make sure that these are congruent. The opposite sides are congruent. So the diagonals end up bisecting each other. Okay? Let's look at these. Hopefully that worked out well for you. The parallelogram opposite angles conjecture. The opposite angles of a parallelogram are what? Opposite angles are congruent. You already wrote that on your quarter sheet of paper. Consecutive angles of a parallelogram, are they the same? They're supplementary. We talked about that a minute ago. Supplementary. And thirdly, the diagonals of a parallelogram. Well, I'm going to write the word bisect on here. They bisect each other. Okay? So they cut each other in half. Okay? They cut each other in half. So that midpoint, that E, was the midpoint. Okay? So we look at this parallelogram here. It says the measure of angle A is 124 degrees. I think you need to write that on there. Okay? Whenever it tells you anything, you need to mark it on your diagram. Okay? Make sure it's marked on your diagram. Next one. That says AB is 15, so I'm going to mark that down. That says BD is 8. Okay? From there, I can tell a lot of stuff. Lots of stuff I can figure out here. How big is angle B? How are A and B related? They're supplementary. So I take 180 degrees minus 124. What does that give me? 56. Thank you very much. So this is 56 degrees right here. What about the measure of angle C? What's it going to be? 56 degrees. You don't have to do any math for that because opposite angles are congruent. Okay? How big is angle D? 124. I don't need, it's not asked in the question, but I can just write that out there. How long is AC? Same as the other one across from it. So those two are the same. So it's 8. How long is CD? 15. Okay. How could they make this more challenging? Yeah, they could put variables in here. So instead of just saying that this is 8, they could say, hey, this side is, 2x plus 4. And we had to say, hey, 2x plus 4 equals 8. And then we'd have to subtract 4 like this, get 2x equal 4, and then divide both sides by 2. And we have to solve something like x equals 2. Nope. Number 2. Example number 2. Okay. Why don't you guys go ahead? Why don't you mark your diagrams? Mark your diagrams. Go across for this. Mark your diagrams. And why don't you guys try number 2 on your own, based on what we've just talked about. I want you to do it on your own. I don't want you just to wait till I do it and copy it, like the parallelogram earlier. Some of you did. I want you to actually, Tyler Cox, work on this right now. Number 2, the example. I called you out. I'm recording it. It's online. It's going to be on the internet soon. Everyone internationally, all across this world, into the solar system will know that Tyler Cox did not want to do it on his own. He wanted to wait for me to do it.
Here, well,
Richardson, stop looking around. Get to work. Sam, get to work. Right, stop distracting people.
No.
Mitchell, get out of here. Go in the hallway, Mitchell. Take all your stuff, go in the hallway. After I've corrected 4 people, don't just do exactly what they were doing. That's just stupid. Take all your stuff, get out of here. On your tests, it said to show all your work. I think those are the first words on your test after like writing down your name and the date. Okay? You need to show all your work. If you don't show work on stuff, you're not going to get credit. If we look at this last problem, I showed my work. It was right here. After that, everything else was obvious. Okay? If you put something in your calculator, that's work that needs to be shown. If you did some work in your head, there actually is physical work like finding these parts, you need to write it down. Okay? Keep that in mind as you may get your test back soon or your grade back soon. Angle ABC means we start at A, we go to B, we cross over here to C. It means this angle right here is 79 degrees. All I'm doing is I'm labeling my picture. Whenever they give you stuff, label your picture. That's the very first step you should do for everything. The entire diagonal is 15, so I'm going to write 15 right there. The entire other diagonal here is going to be 12, so I'm going to write 12 here. What is the measure of angle ABC? 79 degrees. Why? Opposite angles are congruent. Okay, in a parallelogram, opposite angles are congruent. This is 79 degrees right here. Okay, how big is angle DAB? Starting here at D, going over to A, and going up to B. How big is that? 101. This whole angle right here is 101 degrees. You probably have to show some work on that. All you have to do is write this down. Equals 101. Not tough, but you do need to show all your work if it asks you to show your work. This is 101 degrees. Okay? Why? Why are they supplementary? What's their relationship between the angles? They're consecutive angles, so that makes them supplementary. Okay? And that's what you need to say. You need to say consecutive angles are supplementary. That's it. Okay? So what would be the measure of angle BCD? Rashad? Measure of angle BCD? It's not one of the choices, it's just one thing I want to ask you. What's the measure of angle BCD? 101. Why? You can give me 2 different answers, but either one would be right. Could be. Why would you do that? You don't know? Okay, then tell me a different reason. What's the relationship with the 79 degrees? Or the 101? How is this angle right here related to any other angle that we've already done? Are they opposite angles? Are they consecutive angles? Are they alternate interior angles? Same side interior, same side exterior? What are we dealing with? Why are they supplementary? And which ones are supplementary? They're consecutive. Which ones are consecutive?
I don't know.
A. First off, A and C are not angles, because you could say this is A, or the whole thing is A. And A and C would be opposite angles. Yes, you could say this angle right here and this angle right here are consecutive angles, and thus they're supplementary, which tells us this. Thank you, Rashad. That's what I'm getting at, is you need to be able to explain why, not just write some number down. Which is more difficult, isn't it?
Yeah.
Which is also the reason that when Mitchell asked me earlier, hey, do we have to write a reason or do we get no credit? I said, yeah, you got to write the reason. Because the reason is what actually helps your geometric concepts. That's what builds it. I taught geometry for several years. I know that you're going to need to know why. That's the more important thing. You can do it, but why? Okay. How long is AX? 6. Why? Go back to the reasons we wrote down. We just had 3 things. Just go back to the top of the middle of the page. Why? Okay, so here's what you're looking at. You're looking at these things here. It's either reason 1, 2, or 3, and you need to just state it out loud. Don't just say 1, 2, or 3. Tell me the reason that's actually underlined. Janelle, you can do it. You were said something about diagonals. Does anyone up there have to do with diagonals except for one of them? Perfect. That's exactly right. Why? Because the parallelogram diagonals conjecture. That is 100% right. You are the smartest woman in the world. Great. BA. How long is BA? 15. BA. BA is right. Okay, so this is BA.
Well, I thought it was 15 because, is AC the 15?
And AC.
Oh, just kidding. AC's 12. I'm going to say 12. Is BA 12?
BA is not 12. Can we determine how long BA is?
No.
No, we cannot. We cannot determine that. Okay, we don't know how long that side is. We will be able to once we learn more about our angles, but at this point we can't. How long is CB? Can we figure this part out? No. What about CX?
Yeah.
Yeah. How long is CX? It's 6. Why? But why? Tell me a reason why. Parallelogram, diagonals, conjecture. That's it. That's the reason why. Okay. Number 3. I'm not trying to make this more difficult than it is. You might seem like I'm really trying to be this terrible person making this more difficult than it is. I'm not. I'm just trying to teach you that you need to have a reason why. Number 3. It says measure of angle of 9 is 88. I'm going to label that on the picture. It says measure of angle 2 is 36. All right. Ignore this for a little bit. This part right here. Just ignore that part. Just for a little bit. We're going to come back to that in just a second. We're going to figure out what all these other measures are. Okay? And I want people to tell me reasons why. Okay? Let's do this not numerically, but we'll just start from the inside. Janelle, what's the measure of angle 11? 88. Why? Vertical angle. So if you don't know why, you better write measure like something like this. Measure of angle 11 equals 88 degrees. Why? And you have to write down something like this. Vertical angles 100. Okay? So if you don't know why, you better write down why because you're going to have to do this later on. Tyler Cox, how big is measure of angle 10? 88 is incorrect. 92. Why? I need a reason. I've heard the right answer already. Someone just set it up here. It's 2 words. Consecutive is not correct. You're just throwing out random answers here. Okay. Linear pairs. Well, that means these are on the same line. They're right next to each other. They're going to actually form 180 degrees. When you say linear pair, I know it means they're supplementary. 38 and 92 added together equals 180. So they're on the exact same line. And right next to each other. Measure of angle 12. Measure of angle 12. Please, Tyler.
Would it be 92?
92. So I'll give you one reason why. There's many reasons why, but why?
Betty would be a linear pair.
Okay. With which one? Yeah. So 12 is a linear pair with either. Well, no, it's not with 10. It's actually a vertical angle with 10. So those two are vertical angles. Could be a linear pair with 9. Could be a linear pair with 11. That's two different ways of thinking about it. Okay. Let's look at number 6. It's measure of angle 6. What do you think? 128. Why?
I added,
Which one? Which angles?
I added angles 12 and 2 together.
What'd you get there?
140.
You got 128 there.
Oh, wait. That's after 180.
Okay. So he's saying because this is a triangle right here, he used the triangle sum theorem to say that the measure of this is going to be 180 degrees minus 36 minus 92. Which should give you, let's see, 52 degrees. That's 52 degrees. Sounds good to me. What's up?
I have a question.
Yes.
Are the angles, like, angle would be like the whole angle together, would that equal 90 degrees?
Not necessarily.
Okay.
That'd be a really easy way to do this. Okay, now we have to look at this. This is a parallelogram, right? So I mean, these sides are parallel. So basically, I can extend this line and look like this and look like this. Here's a transversal that cuts through these. How is 52 related with 7? They're alternate interior angles. They're between the two parallel lines. So that means they're interior. They're between them. They're interior. And they're on alternate sides. This one's sort of above it. This one's below it. So I would say the measure of angle 7 equals 52 degrees. Why? Because they are alternate interior angles. And I'm going to write congruent on here. Alternate interior angles are congruent. Okay, if I was writing a reason why. Okay, if we know this is 52, we make a conclusion about angle 3 over here. Okay, that's probably going to be 36. Why would it be 36? Because you could use the triangle sum theorem right here. Sounds good to me. Now what do we do? Okay, you see angle 5 here, and what do you think it is? Oh, how would you figure it out? Okay, so you're looking at 4, this one and this one. It looks like we have 2 unknowns though. 4 is 42. Oh, it is 42. Sorry. I thought that was just a whole one. Okay, so that's 42, that's 88, and you can figure that one out, right? No. Apparently I didn't label it on there. I don't know why I didn't. That would have made it much easier. Okay, so triangle sum over here. So what's the measure of angle 5, Janelle? 58 degrees. Okay. Now, I'm going to continue to write on this because this is going to look completely ridiculous. But this side is now parallel to this side. I can talk about how this angle and this angle are alternate interior angles as well. This is also 58 degrees. This is a huge mess. This would have to be 42 degrees. These are also alternate interior angles. Yes, ma'am.
How did you get 58 for angle 5? 42 plus 88 is 130.
Yeah, that's kind of mysterious to me. So you're saying plus 50 would equal 180. Well, I do not think that's 50. I think that's 50. That's going to really confuse things. That one's definitely 50 as well. I just trusted that people knew how to kind of. Okay. Last thing here, it uses the same picture. Hopefully that wasn't very confusing. Hopefully you can use that later on. It says that AE wow, AE, this part right here. This is really getting gibberish. Is 2x plus 4, and it says that all of AC is 36, so we could say 36 equals 2 times 2x plus 4. Why would I say 2 times 2x plus 4? There's 2 of them. Basically, this is 2x plus 4, and since this is a diagonal that's being bisected, this is also 2x plus 4. So the whole thing is 4x plus 8. Could you guys figure this one out on your own? Yeah. Just because of time, because the bell's going to ring in about 30 seconds, I'm going to say that's good enough. I bet you guys can figure this out without too much more difficulty.